It's not every day you get to meet one of the top leaders in research in the world. I'm here with Yossi Matias. In your 18, almost 19 years, and if you times that by 7 dog years, that's a big number, you've been at Google, and your son, actually, his son has created a lot of music that's been on Broadway that's amazing, and his other son has done like 1,000 interesting podcasts. So not only has he been an important leader at Google, but his kids are wonderful. So that says a lot about the guy. Okay, but that's not why we're here. So you're 19, close to 19 years at Google. How has the focus for Google research shifted? What was it originally? How have you guided the shift in AI research from theoretical to more a practical use? Harvard, the Lawrence School of Sciences was very theoretical, and William Barton Rogers founded MIT around the Industrial Revolution because he wanted students to work with industry and work with their hands. How are you, Yossi, having Googlers work with their hands, work with industry? How are you going from theoretical to practical? So that's really two questions. What's been the shift, and what are you doing? And it's great to see you, Yossi. Thank you for being here today.
Yeah, thanks, John, for inviting me. And well, great to be here virtually. Sorry, I'm not there in person. I was looking forward to it. And thanks, of course, for the kind introduction. And of course, first and foremost, I'm proud of my family, my daughter and 2 sons, and of course, my wife and everybody. AI and Google. Yeah, so AI, of course, is one of those amazing technologies. It was always there, right? I mean, of course, as many of us computer scientists know, over the years, the definition of AI has shifted and changed. Some aspects are kind of steady, some of them are kind of evolving. You know, from some point of view, AI was already in our products from whenever I can remember that, starting with, say, autocomplete in search, which is one of the projects my team have been working on, leading since its early days. Which essentially is kind of an AI, if you will, guessing the next character or next word, which of course is at the heart now of generative models, even though the technology was quite different. Or think about Translate in the early days, mostly statistical based, and obviously at some point we got this neural translation that got us into the next level. So some shapes and forms were always there, but there was always this premise of neural-based AI, which was going back to the 50s or 60s, and obviously this is a revolution of the last 15 years or so has been quite profound. So we're blessed to have at Google some of the top researchers, and of course having the transformers coming out of Google Research in 2017 was a meaningful moment for all of us in generative AI. And so what we are seeing now is really kind of a transformation where AI, rather than being more kind of ad hoc solutions here and there, which as meaningful as they are, obviously with billions of people using those products, they are quite meaningful. Now it's actually transforming every aspect of industry, products, science, business, and so forth.
Great. Yossi, what are a few of the research breakthroughs or discoveries that you are most proud of, and why are you proud of them?
Well, before even getting to those, I'd like to actually touch on this notion of the connection between research and research breakthroughs and the impact that we have in our products and more broadly. And to me, this is actually the part which I found extremely exciting, especially speaking at MIT, where just obviously one of the leading places for scientific research. And my roots are in research, even though a lot of my time, most of my time at Google was on leadership in search and products. So, and my passion has always been in this, both the research aspect and the product impact on people and society and so forth. The most exciting aspect from my point of view is really how we're actually driving scientific research motivated by real problems and then applying them back into real life impact or scientific impact. Now, to some extent, this has always been the case. I mean, if you think about some of the big inventions or big steps in mathematics, many of them were motivated by applied problems in physics and other disciplines. And similarly, I like to call it curiosity, um, intentional based curiosity, which is we're curious as scientists, we're looking into research questions, but quite often it's great to have the right motivation to doing that, which is to really solve an important problem. Now, this cycle of getting a research motivated by real world impact and then having the scientific breakthrough that is done in collaboration with the scientific community, and we're publishing in peer-reviewed journals and venues, and vetting it properly, and of course building on a lot of scientific progress, and then taking those breakthroughs and applying them back to impact. This is what I would call the magic cycle of research. And this is not new. I mean, this is something that, for example, when I was remember fresh PhD out of my PhD program and as a research scientist in Bell Labs, even though I was in the Mass Center, which was kind of a place of some of the most foundational research out there, a lot of my own research was motivated by actually these kind of questions, and it had this kind of impact back. And similarly, I've seen it for many other researchers around me. Now, one thing that I see differently is that it used to take years quite often for this so-called magic cycle to actually occur, whereas now I see that happening in months. So back to your question of what's exciting me, it's really those different research breakthroughs in all areas that we're dealing with, anything from foundational machine learning to applied machine learning, to algorithms, to optimizations, to computing systems, to quantum, and so forth. In each of these fields, we see those breakthroughs that are actually making those back impact on what we're doing. And also quite excited about the breakthroughs we're making in areas such as healthcare, education, climate crisis. These are areas where making those scientific progress, research progress, actually leads into impact that is really impacting society and the climate. So each of those I find extremely rewarding, not only in the intellectual curiosity of actually addressing them, but then taking that and applying it back to actually get into the impact that we'd like to get.
Yep. So Yossi, I know you're working with quantum computing and AI, so I want you to comment on that. And I know you've said you don't want AI to replace human ability, but to enhance it. So I want you to comment on that. I'm just foreshadowing you and giving you a heads up. But before you go there, who in organizations as large as Google do you think should be responsible for AI safety? Is that a concern that everyone needs to worry about? Or is that one for one department? Is that one for the research department? And how does it affect what you choose to focus on for your research? And maybe as context, can you maybe explain, how big is your team? How many projects? I mean, I know like CSAIL is 1,800 people, 1,800 projects at MIT. Give us a sense as you go down that one.
Yeah, let me start by actually describing the scope of what we're doing. So Google Research, since we are looking into everything that is that can be transformative into the future of all the products and anything which is in the scope of what we're working on, as you can imagine, it's pretty broad because of the scope of what as a company we're dealing with. And as I pointed out, this applies to anything from foundational research to foundations of machine learning and algorithms, to applied ML and algorithms, to systems, and also societal centered AI. Namely, this touches on the question of AI safety and so forth, which is to better understand how the interaction of AI with society, and of course quantum and the application domains of health and so forth. Now, an important aspect of talking about the nature of research at Google is that we are not seeing ourselves as a place where we're looking into research results and then throwing them off the fence for somebody else to pick up. But actually, that magic cycle that I discussed earlier, the beauty is that this magic cycle is really part of what we're doing. This is the nature of Google Research, is that we're not only doing the research, but then also working with the right product teams or partners, internal or external, depending on the technology and the project, to actually bring it all the way to real life kind of applications. And let me perhaps double click on a couple examples. But I should also note that research is not done only at Google Research at Google. We have amazing researchers also as part of the product teams and other research organizations. Of course, we have Google DeepMind, which is an amazing research organization. Here's an example. I have a team that looked into how to, as one of my roles, I was leading also crisis response at Google, namely how to provide actionable information to Google search whenever there's a big natural disaster, crisis, or otherwise, because people are turning to Google for this information. And to that end, we actually launched at Google Search something we call SOS Alerts, which bring actionable information to people during crisis. Now, in the course of doing that, I found out that one of our major, the most significant natural disaster in terms of casualties, which are floods, there's actually no known solutions. And in order to be helpful with that, you need to actually predict where floods are going to occur, because that's the way to keep people safe. Now, when talking with all the experts in the world that I got to talk to, the unanimous answer I got was, this is too hard problem to actually solve. Now, we decided that perhaps it's an opportunity now to actually take machine learning and cloud computing and computational power that now we have and do something about it. Fast forward, we now have, we did make some progress on bringing together machine learning and hydrologic simulations, and published a paper in Nature which discusses what we call a global hydrologic model that essentially enables us to learn from all the data points that we have on floods and be able to make predictions on where floods is going to occur. Also leveraging on progress that we have on nowcasting of precipitation, which obviously is one of the factors leading into that. Now, by the time we published that paper in Nature, we already had a system that supports flood prediction in over 100 countries, available to everybody to actually check out in what we call Flood Hub, and actually in 150 countries available to researchers and experts. It's the same team. So the same team that actually developed the science and published a paper is the same team to which I'm actually pinging and asking what's going on with the flood in that place, because that's kind of the embodiment of taking the research results and actually making them to work in the real system, and also making it available through our search and maps, and whenever is needed, working with the right product teams. Similarly, we have related kind of magic cycle examples in healthcare and other domains. To your question about AI safety, so obviously the AI is such an important technology and so powerful that we need to treat it extremely seriously. As a company, we were actually, I believe, the first or the earliest to publish what we call AI principles back in 2018 that talks about the need to develop AI from the start with considerations in mind of safety, security, privacy, making sure it's not biased, and so forth. But importantly, it's not only about taking those as guidelines of development, where we develop and look into how we make progress with our research and technology development, but also actually having teams working on how to advance many of these considerations. Now, I think there's still a lot of work to be done on that. So I think that everybody working with AI obviously need to take those consideration into account, like we do with security in every software development. And at the same time, it's important to keep also driving the research to look into how to actually address these considerations in years to come. And again, this is a highly important topic that we need to discuss also, obviously, in various levels involving, this is kind of a global consideration that we need to, as a society, to take it into account about how do we address the potentials as well as risks as we have AI developing in the pace that it does.
Yep. So can you just paint us a picture? How many projects does Google Research work on? Can you tell us the budget, or is that something that you don't want to put out there? Like, just give us a sense. Are you the equivalent of like a major university research? Like, how do you, if you met someone on the street, how would you explain it?
I would say it's pretty broad and pretty substantial.
Okay, great. So you heard it here first, broad and substantial. No, I just, with the federal government talking to universities about their research, I think, Bell Labs, which you worked at, played an important role at a certain time, and I do think you play a certain important role at this time, given the fluctuations and how things are going. The two other questions, quantum computing and AI, and you said you don't want AI to replace human ability, but enhance it. Love to hear your thoughts on that from where you sit. You get a lot of input on information, and you make a lot of decisions running what you do. How do you see those two topics?
Sure, quantum is one of those areas that is really exciting, and actually connecting back to my Bell Labs day. Richard Feynman already kind of predicted that quantum computing is going to be quite important to actually understand better universe being quantum. Just yesterday, we highlighted as 100 years for quantum mechanics, so a lot of nice posts out there with reminders of timelines. To me, one of the important milestone was Peter Shor's algorithm on factoring, and as a fun fact, we got to overlap when I was in Bell Labs right after my PhD. His office was just across mine, and of course now he's a esteemed professor in MIT. And obviously, Shor's algorithm demonstrated in a very strong way the fact that with quantum computer, we could solve this problem that has such a vast impact, and do that exponentially faster than anything known for a classic computer, anything assumed to be known, to be available. And this was a big aha moment, of course. Now, since then, we've seen pretty significant progress on so many aspects of quantum computing, on the theoretical aspects of understanding better the computation, of also highlighting many other applications that are going to be, possibly unlocked with quantum computing. On our part, we're really excited about the investment that we're doing in quantum computing. I was just recently in our quantum AI lab. This is part of our Google Research organization. It's based in Santa Barbara, looking into, the team is well on their roadmap of, developing the hardware. We had a big moment a few months ago with the Willow chip, also demonstrating, that we can solve a benchmark problem in under 5 minutes that otherwise for a classical computer, it would take what is called 10 septillion years. It's 10 with many zeros after that.
So and, the Rubik's Cube can be in 46 quintillion different positions. So that number you just said is multiple Rubik's Cubes, and that's a big number.
It is. But importantly, also a big progress on what we call quantum error correction. So showing that actually as we scale the number of qubits, we can actually reduce the quantum error, which is one of the hurdles, technological hurdles. So we see good progress, obviously on our team. We see that also in other teams in the industry, which is great. And we start seeing more and more potential applications for that. My personal prediction is that as we're going to get even closer to quantum computers that work, we're going to see many more use cases that we're not even envisioning today. Just observing what happens with machine learning once you throw in, you have 16,000 people who are coming to NeurIPS, working on new ideas, and you see the progress doing that. So certainly I expect that to have big applications on many areas in material sciences, in healthcare, and energy, and so forth, and many disciplines where actually the notion of better understanding how simulating the world and molecules and other stuff, or just solving computational problems exponentially faster. Again, quantum computers are not going to replace, of course, all known problems. I don't expect any phone device to run on quantum. On the other hand, it can unlock many opportunities out there, and we see some great progress.
Great.
So really excited about it. Again, this is going to be a step function. It's something, of course, that people are debating about the time where it's going to be applicable, etc. I think it's really on the horizon. We see good progress on the roadmap.
Yeah. So I want to ask that last question just before I do. I want to tell the audience, Yossi spoke the most at our Davos event back in January, we had a panel first thing in the morning, in the middle of the day, and at the end of the day. And I think you know if you speak at 3 events, you get a Chia Pet. So just because you spoke on 3 panels doesn't mean you're eligible for the Chia Pet. And he and I skied the day before in Davos. And Yossi, do you think we should get a lot of stakeholders together to ski the day before and talk about these big ideas and then do the event? Will you help be a stakeholder in this January 21st event coming up at Davos?
Well, I think that part of the magic of innovation in both technology and research is really people coming together, exchanging ideas. I mean, this has been my experience always as a grad student and as a researcher in Bell Labs. And now at Google, the fun part is really to come together, to brainstorm, to come up with ideas on things that we never anticipated coming up, and to try out various stuff. So really intrigued by your initiatives, John, and would love to keep discussing them. And thanks for being such an amazing photographer.
Yeah, I photographed him skiing, and he liked that. Okay, so the last question that I think a lot of people here have been talking about all day is, you said you don't want AI to replace human ability, but to enhance it. What areas do you see AI being able to enhance it, and what are you most excited about on that?
First, let me actually touch on more the societal question, which I think we should all keep in mind. AI is so disruptive that it's going to have impact on so many aspects, and it's going to have huge benefits. We also need to be cognizant to the fact that it's going to impact so many different fields, and as a society, we need to pay attention to that. So I think that the notion of skills and education for the future generation and so forth are so important here. And related to that, there are certain areas that AI can already empower professionals quite profoundly. I mean, one area that I'm extremely excited about is healthcare. It's not new entirely. We have this legacy project of a paper that showed that we can use AI with image classification to identify a condition called diabetic retinopathy, which can lead to blindness if not treated. There's a shortage of 100,000 doctors, experts that can actually do that kind of screening around the world. And a landmark paper that actually got one of the top papers of the decade in JAMA, Journal of Medicine, was showing that we can do that with AI. Fast forward today, we already have in the clinics in Thailand and India a system that is using that AI and that screened over 700,000 people by now, and is now poised to screen over 6 million in the next decade. So that's an example of actually helping out filling gaps. But the one area that I expect actually AI to do much more is really helping out doctors and nurses and healthcare workers. Example is that we looked into a couple of years ago, we showed that you can take a large language model and adapt it to medical information. For the first time actually passed the US Thai medical exams in a passing score. And later on showing that we could do that with 91%, which is more than expert level. But interestingly enough, talking about the magic cycle, by the time that original paper was published in Nature, we already had partners actually using these language models to help out. So for example, I was just visiting a hospital, Innovation Hospital of HCA in Lake Nona in Orlando, and show how nurses are using these language models for helping out with end-of-shift reports. There are hundreds of thousands of such reports. If you can make their work better and reduce errors, this actually translates ultimately to saving lives. And this is just the beginning of what we can do with that. Think about all the areas where actually generative AI can help doctors, nurses, healthcare workers, make healthcare more equitable worldwide. So this is one example for aspect. Another aspect is education, where we're looking actively into how to actually empower teachers and how to provide a kind of teaching experience to more students around the world, both in places that have a good education but can be 10 times better, and places actually are lacking the kind of resources for education. I was just last week in this big conference of education in San Diego, where educators kind of came together, and you see all these AI startups emerging on private tutor and helping teachers, etc. And we're doing our share on something called LearnLM, which is a model that is supporting many of these technologies, hopefully into the future. And perhaps last but not least, one example of the recent work that I'm really excited about is something we call co-scientist, which is about how to use AI agents actually to help out researchers in their own research. So the idea is that a researcher can pose a question to the AI system, and the AI co-scientist is then going to have agents that are going to do sifting through literature, creating hypotheses, simulating, emulating them, trying out to see if they make sense, try to rank them, come back with a result, and essentially accelerating scientific discovery itself. Now, just imagine that every researcher and every grad student for that matter, or postdoc, could have actually AI co-scientists helping them accelerating scientific research. We did some early experiments and collaboration with Stanford and with Imperial College London, and got some examples where the AI co-scientist is helping with hypothesis, novel hypotheses for things that took years actually to come up with, or to actually come up with a proposal for drug repurposing. It's quite nascent, but I think this approach is going to be one of those examples of empowering scientists and similar approaches of agents empowering so many other professions. So makes me really optimistic about how can we actually enlist and engage technology in really solving some of the biggest problems that we have in society, and as well as actually get us into a new level of productivity in businesses.
Thank you, Yossi. So, Yossi, if you speak at their Stanford event or next year at Davos, you will earn that Chia Pet, something to look forward to. I want to thank you. You're very thoughtful. I can tell that you are using your role at Google in a way to have real impact. I know how sincere you are about trying to address sustainability and climate, and also thinking about AI. It's been a real privilege to interview you today. I was a few minutes late because the co-founder of Perplexity and I were talking about how awesome you are, and I should have been here right at the beginning. All right, ladies and gentlemen, Yossi Matias.